Here we have a very difficult implicit differentiation. I know it's difficult because I see I have two product rules. I have x to the fourth times y to the sixth, so there's one product rule, minus 20x squared times y squared. There's a second product rule, and that equals 30. So really as tough as it could get, just because we're having more than one difficult rule in one problem. For these, I'm going to do the derivative of the first times the original second plus the derivative of the second times the original first. I'm just going to take it piece by piece, and I'm only going to put a dy dx if I've taken the derivative of a y term. So looking at this first product rule, I have x to the fourth times y to the sixth. So derivative of the first, x to the fourth, is 4x cubed. It does not need a dy dx because we did not take the derivative of a y term. So there's the derivative of the first. That gets multiplied by the original second. Product is always plus. Now I'm going to look at the derivative of the second term, which has a y in it. So this is going to have a dy dx as part of the derivative. So the derivative of y to the sixth is going to be 6y to the fifth. This is going to get a dy dx. I always like to put it at the end. You don't have to, but I'm going to, because normally when we solve for a variable, it's after the number. So I'm going to put it at the very end. So there's the derivative of the second term. Y to the sixth is 6y to the fifth, needs a dy dx. Derivative of the second is multiplied by the original first, though. So I'm going to put that x to the fourth in front there. It's just going to make it easier when we solve for dy dx to have them all at the end. All right, there's my first product rule. Not too bad. Now on to my second product rule. I'm going to do the derivative of the first. So derivative of this negative 20x squared is going to be negative 40x. That doesn't have a derivative of y on it, so it doesn't need a dy dx. So derivative of the first is just negative 40x times the original second is a y squared. Now we just did the derivative of the first times the original second. Product is always plus. Now we can do the derivative of the second times the original first. The derivative of the second term, y squared, is going to have a dy dx with it. So derivative of y squared is not just 2y, it is 2y dy dx. I'm going to put that at the end. Leave some space because that derivative of the second gets multiplied by the original first. Negative 20x squared equals the derivative of 30. We don't want to forget to take it. Derivative of 30 is just 0. So I'm just going to double check this before I move on and make sure that I have everything right. So derivative of the first is just 4x cubed. That looks good. We put the original second with it. I like that. Derivative of the second is going to be 6y to the fifth dy dx times the original first is an x to the fourth. So there's a good second part of a product rule. Next one, derivative of the first is going to be negative 40x. Original second is y squared. Doesn't need a dy dx because we did not take the derivative of y term. And then derivative of y squared was 2y dy dx times the original first is a negative 20x squared. So that all looks good. I'm going to take a second here and see if I can simplify anything here. I'll just rewrite it. So we have 4x cubed y to the sixth. There's nothing to multiply together there or combine. Plus the next one, maybe I'll put the x's before y's just to keep the same pattern. 6x to the fourth y to the fifth dy dx minus 40x y squared. And then this one is really the only reason why I'm rewriting it, because I have 2y times the negative 20 x squared. So 2 times negative 20 is going to make it a negative 40. And then we have an x squared y dy dx. You do not have to put x's before y's, but in math, generally to keep organized, we do things alphabetically. So x's would go before y's in the alphabet, so they would go before each other here. But really the only reason why I would take a second to rewrite this is that term there, because you have 2 times negative 20, which is going to be a lot faster to type in your answer on WebAssign or something if you actually multiply them out. 2 times negative 20 is going to give us negative 40. There's an x squared and a y in there before the dy dx. All right, very tough derivative, but now we're ready to combine like terms. I'm just gonna keep the dy dx's on the left, I guess, and move everything without a dy dx to the right. It doesn't matter which side you pick. So I'm thinking, do I keep or move this first term? Well, I said I'm gonna keep dy dx on the left. This doesn't have a dy dx, so I'm gonna move it to the right by subtracting it over. So on the right side, I'm gonna have a minus 4x cubed y to the 6. So move that, and then I'm thinking, do I keep or move this term? It has a dy dx, so I'm going to keep it. So we keep it on the left, 6x to the 4th, y to the 5th, dy dx. This next term, I'm thinking, am I going to keep or move this negative 40xy squared? It doesn't have a dy dx, so I'm going to move it. I'm going to add 40xy squared over. And then this last term, I'm thinking, do I keep or move it? It has a dy dx, so I'm going to keep it on the left. So I'm going to keep minus 40x squared y dy dx. So on the left, I've kept the two dy dx terms, and on the right, I've moved over the two that do not have a dy dx. And now my next step is going to be to get dy dx by itself by factoring it out. So I'm going to keep the dy dx outside, and in front of the first term is a 6x to the 4th, y to the 5th, minus a 40x squared y equals, and then I just have to copy down, minus 4x cubed y to the 6th plus 40xy squared. And the last thing I need to do to get dy dx by itself is to just divide both sides by 6x to the 4th, y to the 5th, minus 40x squared y. 6x to the 4th, y to the 5th, minus 40x squared y. There is my derivative. Here is my dy dx.